quick little demo of what I did to help out Massimo Di Stefano access the OAflux data, and just showing what I did here in case it's useful to someone else. So he was looking at this web page at Hui here, and when he looked at the data access, he found that it was the data was available through an FTP site. And so what I did was I went to the FTP site, and when I looked at the, I guess I've logged out here, but it doesn't really matter. All I did was I got all the data files from this directory, which looked like these OAflux.nc files, except they were gzipped. So I ungzipped them, and then I also did actually ran a little script here, which went through all these files and converted the files which were in netcdf3 format here to this D6 says deflate with level 6 deflation. This is something that's built into the NC copy routine that comes with the Unidata netcdf distribution. So this just goes through all the files which were previously netcdf3 files and converts them to netcdf4, which supports this deflation. So it's a non-lossy compression. And actually, these files that these files that you can see that are uncompressed, they're internally deflated, but not gzipped. So these files actually are slightly smaller than the original gzipped files, and yet they can be you can binary access portions of the data without unzipping the entire file. So it's a better way of doing things. And then I wanted to see if I could create a single aggregation out of all this data. I took the OAflux data and I looked at it, and I ended up looking at the data, looking at the individual files to see if they were CF compliant or not. And that ended up, I ended up figuring out that the longitude units needed to be changed 2 degrees east, and the time units they just said month or something like that. And I changed them to days since the beginning, and with a starting value of 15, and then I just did an increment of 365.25 divided by 12. There's different ways of doing this, but anyway, and then I aggregated the files for each variable. Each month was in a separate file, so I just there's a little aggregation tag you can use here to scan all the files that have this kind of evap PR OAflux blah blah.nc and create, and then you can union all these. So this aggregates them in time, all those files that start with evap PR. And then this aggregates all the different variables together. And because the variables in each file, the error was just called ERR, I changed the name to bring them all together. Of course, I didn't want there to be just a single ERR variable, so I changed the names to evap.pr.err, LT, latent heat flux error, so on. So when they appear in the combined data set, they're distinguishable. And so this took about half an hour to figure this out. But the result is kind of neat. And so if I go back to the web browser here and I look at, if I put this file, so this is aggregated this is a virtual aggregation then of the entire OAflux turbulence data set there. And I haven't really changed the original files except for the deflation. So all the addition of metadata and stuff happens virtually through that little bit of XML. And then you just open up that file, and through this, this URL here, and then it's available through all these different services. The OpenDAP service. So if I click here, just to say, to take a look at the data, sort of data set variable view or whatever, I can see there's a variable called evaporation. Actually, let's just scroll down to the bottom, and you can see here that all these different variables are here, and they have 648 time steps, one for every month. And so they've all been aggregated. It's all been aggregated together, and the variables are all available here. Another kind of neat thing that you get for free here is because you have this WMS service here, Unidata on recent thread servers includes this little Godiva client which accesses, it does WMS calls to the WMS service to create maps of the data. And so you can actually look at this little guy, pops up the data set here. You click on the plus, it shows you all the variables. Let's say we look at one of the variables here. It comes up and makes a little, map on the world. You can click over here on the right side here and auto scale this, so it looks a little better. Up here you have a calendar, so you could actually you can skip back here by clicking these arrows. Say if you wanted to skip back to December, and you can click that date and you get a new map. You can do things like, of course, you can do, if I hold down the shift key and drag, I can zoom in. So I can look at a particular region and the map gets redrawn at that resolution. If you click on a spot, it'll tell you the value that you clicked in, the upper left-hand corner, and tell you the actual value that you clicked on. And you can also do things like I can select this picture here. Let's maybe I'll zoom back out by see, I'll select another variable. That's an easy way to do it, but I could have just used these things here. Actually, let's go back to temperature again, just because it's simpler to look at. Auto scale again, and let's pick this as a last frame. So I'm going to click here and say last frame, and then let's skip back. Let's skip back a year, okay, and then I'll pick this as the first frame. So now it says create an animation from December 16th, 2006 to December 2007. So we could look at the little movie of the annual cycle here. If I click create animation, it's going to make, it asks me whether do I just want 2 frames. No, I want the full. It thinks it's, actually this is funny, because of the time, it specs uniform, different kinds of time. So really I want 13 frames, I suppose, right, for the full year. So I'm going to click that. But and so now there's the like little seasonal cycle of temperature there. Anyway, actually, if I click a spot now after I've done that animation, it'll ask me at the bottom. It has a new little tag here, create time series plot, so I could actually look and see at a particular spot what the annual cycle looked like, along with the actual values. But of course, now that you've got the data here all aggregated, you can go to, say, if you went to the OpenDAP site and you took this data endpoint, this is, if I copy this, I can go to something like MATLAB and URL equals, that thing. I can treat that like a local netcdf file. So if I have our NC, if I have NC toolbox, which you can get from GitHub. Type NC toolbox in GitHub, you get here, and actually this is the source code. This is the source code, but this is the home page here. You can get the zip file and install it. It's very, very easy. Once you've done that, you can go back and take advantage of the CF conventions that we've implemented here by just opening up this file, say NCGeo dataset, with that UID variables. So now I can say NC variables and see the variables. So there's our temperature variable, temp2m. And so I could say T equals NC temp2m. And let's say I get just the first time step and all the mon values. So size T, okay. So I could squeeze that. Okay, and then I can get, I can take advantage of the CF conventions to get the grid for that guy by just putting this grid on the end. This is a function. This is something you can do in NC Toolbox. So it gets back the time, the lat, and the lon automatically, figures out what those variables are. So now I could do something like image sc, g.lon, g.lat, and then the temperature. And if I do that, I get it flipped upside down. Let's see. Okay, so there is the data with the grid, and of course you got the data here, so you can do whatever you want. So that's about it for the demo.